Earth orbit on a 97.5-degree inclination, launching on a southerly direction from Launch Complex 1 over Antarctica. RAISE 4 and a further 8 CubeSats, collectively known as Innovative Satellite Technology Demonstration 4, is the fourth mission of JAXA's Innovative Satellite Technology program that's being deployed across 2 Electron launchers.
JAXA's goal with this program is to respond to Japan's national and industrial priorities and offer up an opportunity for companies and organisations to test their technologies in space. Here's more from JAXA.
JAXA is a national research and development agency that supports Japan's space development and utilization through technology. Its missions range from Earth observation, planetary exploration, and fundamental space science, space transportation, as well as human spaceflight activities aboard the International Space Station. JAXA also promotes collaboration with industry through research on next-generation aircraft technologies and on-orbit demonstrations of innovative space technologies. The Innovative Satellite Technology Demonstration Program is a JAXA initiative that collaborates with private companies and academic institutions to pioneer the future of space development. Through this program, innovative ideas are tested and demonstrated in space, leading to the creation of numerous new technologies. This marks the 4th chapter of the Innovative Satellite Technology Demonstration Program. RAISE 4, the 4th small demonstration satellite carrying 8 demonstration-themed components, and 8 CubeSats are now heading into space.
RAISE 4, the 4th small demonstration satellite, is designed to demonstrate 8 demonstration-themed components on orbit. Based on requests from the demonstration users, the satellite is operated to provide both experimental data from the component and environmental data during the mission operations. In the Innovative Satellite Technology Demonstration 4, 8 CubeSats are also given the opportunity for space demonstration. Each CubeSat carries a challenging concept aimed at advancing satellite component performance and innovative development methods, which lead to revitalize the space industry and to create new space business models. These demonstrations will help expand the possibilities for future space utilization.
JAXA will continue to take on challenges toward the future of space.
Raise and Shine is the first of our 2 launches for JAXA taking place for this program, with the second one, Kakushin Rising, scheduled to launch in the new year. For today's mission, though, there are 8 technologies integrated into JAXA's 110-kilogram RAISE 4 satellite. But before we delve into each of those payloads, we have an integral milestone to check off ahead of launch.
That's right. Coming up shortly at T-12 minutes, the launch operations team will enter into the go, no-go poll to run a status check across all stations. Our launch director running the count today is Paola Torres-Serralonga. Paola will check in with each operator to confirm that all stations are clear of issues before launch. Let's check in with the operators at range and mission control to hear the go, no-go poll as we count down to liftoff.
And all stations held in mission core proceeding with a go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LDSUP.
LDSUP is go.
The go-no-go sequence is now complete. We are T-minus 11 minutes, 21 seconds and counting. We're go for terminal count auto sequence starting at T-minus 10 minutes. From this time, the three-word procedure is in effect.
Excellent result out of mission control there, with all systems healthy across Electron, and the coming up in just 10 minutes.
Now, we mentioned earlier that the RAISE 4 satellite from JAXA is home to 8 different technologies from a wide variety of Japanese organizations. And JAXA's goal is to provide opportunities to companies and organizations to demonstrate their technologies in space. So here's what each of them are designed to do. The first technology feature is Helios R, a lightweight membrane structure with antenna functions and power generation that's being developed for high-power, high-capacity 5G comms for small satellites by Sakase AdTech Company. The Leomi IoT transmission device by NTT Corporation will test the concept of an ultra-wideband satellite IoT platform, and the Gemini GPU by Mitsubishi Electric is designed to demonstrate high-speed computations for AI processing and synthetic aperture radar reconstruction.
Up next is KIRX. This payload is a water-based propulsion system that will be tested by a company called Pale Blue. Then we have the TDS PPT payload, which is an electric propulsion device demonstrator. This one is designed by the Takahashi Industry Company for ultra-small satellites. Also integrated to RAISE 4 is a radiation-resistant color camera by the Mark Corporation, as well as a next-generation space microprocessor from Mitsubishi Heavy Industries called SOISOC 4. This technology will demonstrate their ability to detect ships from space. They will use AI to downlink only the necessary data and then use that data to perform retraining before updating the payload's AI chip.
And the final tech demo integrated into RAISE 4 is D-Sail, a deployable mechanism by Axel Space that is designed to speed up a satellite's deorbit once its mission is complete.
Wow, it's super cool to see government organizations like JAXA supporting innovative companies like those on board today. We wish everyone all the best in commissioning their technology demonstrations after today's launch.
Avionics LD mission court.
LD avionics.
Avionics proceed with sequence 59 avionics terminal checks.
In work.
Stage LD in mission court.
LD stage.
Stage proceed with sequence 60 stage terminal checks.
Copy sequence 60 in work.
S-band is switched to high power for flight. Stage 1 and 2 high voltage batteries ready for flight.
GC LD in mission court.
LDGC.
GC proceed with sequence 61 launch pad ready.
Understood. Sequence 61 in work.
All pump lips nominal. All engines ready.
Alrighty, let's check in on the countdown clock. We're now at T-minus 7 minutes in the countdown to liftoff. Coming up shortly is when the team issues the command to retract the strongback in preparation for launch. The strongback is the vertical support structure that holds Electron upright while it's on the launch pad and provides stability during pre-launch operations. It also houses essential umbilical connections that supply power, data, and fluids to Electron before liftoff. As we get closer to launch, the strongback will tilt backwards slowly and move away from the rocket to make sure it's well clear during liftoff. We should see that happen from the pad camera we have up on the screen now. And it's a great indicator that we're proceeding well toward an on-time liftoff.
And speaking of an on-time liftoff, we heard earlier from the launch director at the end of the go, no-go poll that all stations are green and go for launch. So let's walk you through what happens during Electron's 9 minutes of flight to orbit. Now, just before we hit T0, all 9 3D printed Rutherford engines on Electron's first stage will ignite, and at T0, Electron lifts off the pad. Now, those engines will burn through the liquid oxygen and kerosene stored in Electron's first stage until that's completely drained of its propellant at around 2.5 minutes after liftoff.
Once we reach that point in the mission, Electron no longer needs the weight of its empty first stage. The Rutherford engines shut down and the first stage separates from the second stage. After separation, the Stage 2 vacuum-optimized Rutherford engine ignites to continue the journey to orbit. Attached to the second stage is the kick stage, which carries the RAISE 4 satellite. Both are protected inside the rocket's nose cone, or fairing, during ascent. But once the first stage is discarded, it's time to jettison those fairing halves as well. This happens just over 3 minutes into the flight, and it's the moment we'll see RAISE 4 against the backdrop of space for the very first time.
Now, the second stage of Electron has the longest burn time across the entire launch, with that single Rutherford vacuum engine firing for over 6.5 minutes to take us from the edge of space to orbital velocity. Now, along the way, the second stage will perform a maneuver called the battery hot swap. And it's an action that's unique to Electron because we use batteries to power the electric pumps of our engines. At around 6.5 minutes into flight is when we swap in a new set of batteries, and that's when we should hear a call out from mission control for that battery hot swap maneuver.
After that, the second stage continues on until around T plus 9 minutes. At that point, the Rutherford engine will shut down and the kick stage will separate to carry on the mission with RAISE 4. From there, it's another 45 minutes or so until we reach payload deployment for JAXA's spacecraft.
Now, of course, before we get to liftoff, we have to make our way through the final count. And that starts when Electron's flight computer takes over command and control of the rocket at T minus 2 minutes. At T minus 1 minute 30 seconds, just after Electron switch over to the auto sequence, we should hear a call that LOX load is complete on Electron. And at T minus 1 minute to liftoff, we can expect confirmation that the launch vehicle's first and second stages are pressurized for launch. Then it's through to T minus 10 seconds when our launch director will begin the countdown to launch alongside the flight computer.
With the vehicle healthy, no issues reported for RAISE 4, clear weather, and the range ready to support, everything is looking great for an on-time launch at 4:09 local time. So, let's raise the volume on mission control and listen in as we approach the final moments before liftoff. Go raise and shine, go JAXA, and go Electron.
LD GC on mission code.
GCLD.
ECS disabled, pad auto sequence is armed. The pad is ready for launch.
Copy, GC. And from now, there should be no red flags on your critical LCCs. Beacon LD in mission court.
LD VCon.
Beacon, lock the auto sequence and confirm.
Auto sequence is locked.
And confirm all flight computer ASCOs are green.
Confirmed all ASGOs are green.
Copy. We'll go for auto sequence start at T minus 2 minutes. LDs go for launch.
Vehicle is fully on internal power. AFTS is green and enabled for flight.
Logs load complete. System is in recirculation. Anti-geyser ring is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge is enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 1.
Beginning pitch orbit. Stage 1 propulsion is nominal.
Successful liftoff for Electron from Launch Complex 1, rising and shining and on its way to space with JAXA's Raise 4 mission. Next, we'll be listening in for confirmation that Electron has passed through max Q, the point of maximum aerodynamic pressure. Once through max Q, the rocket will have endured the peak structural load during ascent, and those loads will continue to ease as Electron climbs higher and higher into space.
Approaching max Q.
Cleared max Q.
HVB discharge nominal.
And there's the call out for max Q. Now those Rutherford engines are back at full power as Electron continues to climb. We are 19 kilometers above the launch pad and traveling at more than 2,300 kilometers an hour and coming up on a series of maneuvers by Electron for its next phase of flight.
First up is MECO, or main engine cutoff, when the 9 Rutherford engines on Electron's first stage shut down completely to allow for the next event. Right after MECO, we'll see stage separation, followed by engine ignition on the second stage.
Now, the engine will then continue to propel Electron and Raise 4 into orbit, providing the necessary thrust to overcome Earth's gravity and reach orbital velocity. Now, let's listen in for those call-outs from Mission Control.
Entered burnout detect mode.
15 seconds to staging.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
Stage 2 guidance is nominal.
As you just heard, that's MECO, stage separation, and second stage ignition confirmed successfully by Mission Control. Next up, we can expect fairing jettison. We've got a camera inside the fairing, so we should get a pretty good view of Race 4 being exposed to space for the very first time. Fairing jettison confirmed, and that's Race 4 on your screen there as Electron continues to carry this mission to orbit. We have a few minutes between now and our next milestone for Electron, which will be battery hot swap for the Stage 2 Rutherford engine. For now, Electron is performing nominally, travelling at a velocity of 8,500 kilometres per hour and currently at more than 133 kilometres above Earth.
Stage 2 propulsion nominal.
Now, the team in Mission Control have been closely monitoring the vehicle's performance and engine power levels in the lead up to the battery hot swap event on the second stage. Electron's Rutherford engine uses a battery system to power its electric propellant pumps. As the second stage continues to orbit, those battery packs are depleting, which means Electron needs to switch to a new set of batteries to keep the engine burning to full duration. Now, we call this mover the battery hot swap, and it's scheduled to take place during today's flight at around T plus 6 minutes and 29 seconds.
When that swap takes place, the old battery packs are removed and fall away from the rocket. The silver pack on the right-hand side of the screen will be the one to watch during that event. When the hot swap occurs, it will disconnect immediately and you should see it fall away out of frame. At T plus 5 minutes on the clock, we've got about 60 seconds left until that milestone.
Guidance nominal. 200 seconds remaining.
HVB discharge holding nominal, approaching hot swap, roughly 30 seconds.
Throttling down.
Battery jettison confirmed.
Hot swap successful.
Nice, a clean hot swap by Electron. The second stage is powering on beautifully, carrying Race 4 to orbit. Stage 2 is now travelling at 16,000 kilometres an hour and performing nominally as it heads toward our 540 kilometre altitude target. Between battery hot swap and SECO is another 2.5 minutes of burn time for the second stage Rutherford engine, which produces up to 5,800 pounds of thrust in the vacuum of space.
Now, Electron's second stage has completed almost all of its stage events during this phase of flight. And all that's left to complete now is engine shutdown and stage separation, which will be a very similar process to what we saw earlier in the launch for the first and second stages.
We're coming up now on the final actions for the second stage. Very soon, we're going to see the Rutherford engine power down and shut off completely for our SECO maneuver, or second engine cutoff on the second stage. Once the second stage's flight is complete, the kick stage, with JAXA's Raise 4 spacecraft attached, will be separated into a staging orbit ahead of payload deployment. SECO is scheduled to take place just a couple of seconds after T plus 9 minutes. Not long to go now.
Guidance terminal, 20 seconds remaining.
SECO confirmed.
Nominal transfer orbit achieved.
Stage separation confirmed.